Good morning, good afternoon, good evening. Welcome to AWS Pi Week and happy St. Patrick's Day. My name is Raymond Lloyd. I'm a product manager with the Amazon S3 team. Very excited to be here today to talk about different ways you can use to manage access to your S3 buckets and objects. In this session, we will take a journey to see the tools that you can use to build up your security posture and access management for your data in Amazon S3. Specifically, we will cover three main concepts. First, we will talk about access control fundamentals, including AWS IAM policy, bucket policy, and two new condition keys that we recently launched. Next, we will go to cross-account access that includes topics on access controllers, Amazon S3 object ownership, and Amazon S3 access points. Lastly, we will go over ways to keep your bucket secure by blocking public access and reviewing the permissions that you put in place with external entities using Access Analyzer for S3. With that, let's dive into the first topic. When you have data in Amazon S3 and have different users using the data, you need a way to give them access. To do that, you can either define an IAM policy in AWS Identity and Access Management or a bucket policy in Amazon S3. An IAM policy is an access policy that you attach to your IAM user or IAM role, and hence it's called identity-based. A bucket policy is an access policy that you attach to your S3 bucket, and hence it's called resource-based. Both IAM policy and bucket policy use the JSON format, so you can easily relate one to the other. Let's go over IAM policy. An IAM policy defines what actions can this IAM user perform. It has three mandatory elements: effect, action, and resource. In this example, we have an IAM policy that allows an IAM user to read and write objects to the bucket called sample bucket Pi day. Now for this IAM policy, the first element, the effect statement, specifies whether the policy results in a deny or allowed. Second statement, the action statement, specifies the action that is denied or allowed. Third statement, the resource statement, specifies which AWS resource the policy applies to. So this is all you need for an IAM policy. This IAM policy effectively allows this particular IAM user to read and write objects to the bucket called sample bucket Pi day. Who gets to apply IAM policies? Well, if you are the IAM administrator for your AWS account, you define the IAM policy and you attach it to an IAM user or an IAM role within your account. You can further allow an IAM user to assume an IAM role. With role assumption, the IAM user inherits the permissions of that particular IAM role. Instead of using IAM policy, you can use bucket policy in Amazon S3. This is a resource-based approach because it defines permissions for your S3 bucket. A bucket policy defines who can access your bucket and what actions can that user perform. It is very similar to IAM policy that uses the JSON format, but it requires an additional principal statement that states who the policy covers. Here in this example, the bucket policy allows AWS account ID 12 ones to read and write objects to the bucket called sample bucket Pi day. The principal statement in bucket policy can accept a variety of inputs, including AWS account and root user, IAM users, federated users, IAM role, assume role sessions, AWS service principals, and anonymous users. You can further add granularity to your IAM policy or bucket policy with a condition statement. Here in this example, we add a condition that only allows access to objects that have the Pi day tag on them. Customers ask us to give them a condition key that reduces the need to update their access policy. Recently, we add a condition key that just does that. S3 resource account is a new condition key that lets you restrict access to your S3 buckets that are owned by a specific AWS account. Before this condition key, you would need to list individual buckets in your IAM policy or VPCE policy. Now with this new condition key, S3 resource account, you simply apply the AWS account ID to this new condition key, so the policy applies to all the buckets owned by that AWS account. Customers also ask for control over the version of TLS that their clients are using. With that S3 TLS version, it's another condition key that we added. This condition key lets you restrict access to your bucket based on the TLS version used by your client. For example, in this bucket policy, we deny put object requests by clients that have a TLS version lower than 1.2. So those are just the latest ones we added, but we have many more condition keys that you can work with. For detailed descriptions, you can go to the AWS documentation page and search for condition keys for Amazon S3. Next, we will move on to the second main topic for today and talk about access within your account versus access across accounts. When you only have IAM users within your AWS account, read or write data to your S3 buckets, you need either an IAM policy or a bucket policy to provide that permission. But as you expand your use of Amazon S3, and sometimes you want to share your data with someone from an external account, if you need to set up cross-account access, you would need both IAM policy in the account that owns the IAM user and bucket policy in the account that owns the bucket. This is because S3 buckets are private by default. For cross-account write, the writer of the data owns that data. In this example, we have a user in account A writing data to a bucket in account B. The resulting objects are owned by the object writer, account A. The objects cannot be read by the bucket owner, account B. The objects cannot be shared by the bucket owner with other accounts, say account C. To allow access in cross-account write, we have to use access controllers, or ACL. An ACL is a list of permissions associated with an S3 bucket or object that allows you to have fine-grained access control. So in the previous example where we have a cross-account data write, if account A writes the object with the bucket owner full control ACL, the resulting object can now be read by the bucket owner, account B. The object can also be shared by the bucket owner with other accounts through object ACL. However, the owner of the object remains the object writer. Because bucket policy is only applicable to objects owned by the bucket owner, some customers want a simpler way to standardize object ownership within the bucket and to leverage bucket policy for access management. For that, we introduce Amazon S3 Object Ownership, a new bucket configuration that automatically transfers object ownership to the bucket owner. Here is an example with a bucket. The object ownership feature has two settings. The first setting is Object Writer, and this gives you the default behavior where Object Writer remains the object owner. The second option is Bucket Owner Prefer. This is the setting that would transfer object ownership to the bucket owner. Let's see what happens after we set object ownership to Bucket Owner Prefer. Here, once you set object ownership to Bucket Owner Prefer, when an external user writes data with the Bucket Owner Full Control ACL, the data will be automatically owned by the bucket owner. This allows you, as the bucket owner, to standardize object ownership within your bucket. It also allows you to control permissions and share the data with external accounts through the use of bucket policy. Now, as your bucket evolves and becomes a central location for storing shared datasets, your bucket policy can become more complex. You will probably take more time to audit and manage it. Amazon S3 Access Point are a feature that helps you simplify access management for shared datasets. In a nutshell, you divide access to your bucket into multiple access points for different groups of users. Here in this example, we divide cross-account users into three groups: finance, sales, and dev. Each group read and write data from a designated access point that has its own access point policy. With Amazon S3 Access Point, you can first effectively decompose your bucket policy into separate access point policies that you can manage more easily. Then within each access point policy, you can further add granularity to your permissions. Lastly, you can use access point to limit access to specific virtual private clouds. With that, let's move on to our third main concept for today. How do you prevent public access? To guard against accidental public access, Amazon S3 Block Public Access is a feature that applies a blanket protection against public access. This feature can be set at the bucket level or at the account level. It provides protection against permissions from ACL, bucket policy, or both. Let's go through an example of how Block Public Access helps secure your buckets. So here is an example. In the S3 console, we have a total of 9 buckets. The access column in the bucket overview page shows the status for my buckets. Here we have one bucket that has public access. And we have another bucket that has objects that can be made public. So after I turn on block public access at the account level, all of the buckets are protected. The 2 buckets that were flagged are now secure and are not publicly accessible. Once you turn on block public access at the account level, this setting gives you the overarching protection against all your buckets and overrides your individual bucket setting. Customer wanted a way to review the existing permissions and prevent unintentional access permission. For this, we introduce Access Analyzer for S3. This feature analyzes permissions for your buckets in an AWS region and provides a simple dashboard that shows buckets with public access as well as buckets shared with external entities. Let's take an example. Here in this example, you can select Access Analyzer for S3 on the left panel. Once you click on that, you see a dashboard that contains Access Analyzer findings. Access Analyzer reveals your bucket policy, ACL, access point, and block public access setting to produce their findings. Here, the first panel, it will list the buckets that have public access at the top. It shows buckets that are shared with an external account at the bottom panel. Finally, it will also tell you the means that grant that access. For example, bucket ACL in this example. Just last week, we introduced a new feature within Access Analyzer to allow you to preview and validate changes to your bucket policy before you save them. When you make a change to your bucket policy, Access Analyzer will identify public access, new permission added, and existing permission removed from your bucket policy. This gives you confidence that you have made the right update before saving your new bucket policy. Let's do a very simple example. Say we have an S3 bucket with an existing policy that allows public access. If you preview access without updating the bucket policy, you can see that there is an existing finding for public access. Now say if you update your bucket policy to remove that public access and to only allow one specific external account to read your bucket, you will see two findings from Access Analyzer. The first one is that you have a new access. The second one is that you have resolved a public access. When you share your bucket with external entities, we generally recommend 3 best practices. First, you run Access Analyzer to understand how your buckets are being shared. Second, you keep public buckets in a dedicated AWS account, so you can enable block public access at the account level everywhere else. Third, you use bucket policies over ACLs to manage permissions. Bucket policies give you one centralized place to control permissions. To recap, today we cover IAM policy and bucket policy. They are the two types of access policy to manage permissions to your S3 buckets and objects. We also discussed 2 new condition keys, resource account and TLS version, to add granularity to your access policy. We also went through cross-account data sharing, how Amazon S3 object ownership and access point help you share datasets across accounts. We also discussed how block public access helps you prevent public access. Lastly, we took a tour of using Access Analyzer to review and validate access that you give to external entities. It's a great pleasure to have you today in my session. Thank you.